Hi folks, so it's Mrs. Allen again, and we are back on 2.5 AP Calculus AB Notes Practice and Test Prep. And so after we went over the derivatives for sine, cosine, logarithms, and a to the x, e to the x forms, now we're going to look at the derivatives of tan x, cotangent x, secant x, and cosecant x. So you might wonder why we did the logarithms and exponentials in this section, and it's because logarithms and exponentials are what we call transcendental functions. They do more than just mere algebra. They tell you, for instance, to say, if you say the log base 10 of 10, it says 10, it really reads in your mind as 10 to what power is equal to 10, the answer would be 1. So it's more than just algebra. So some trig derivatives that we'll have to know. You have the sine and the cosine here. The derivative of the sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. So remember, when we write secant squared, then we have to remember that that's the same thing as if we had secant x squared, like so. And the same thing is going to be true down here, where you have the derivative of the cotangent is negative cosecant squared, so it'll be negative, and then we'll square the cosecant x value. It's just the notation we use in trig because we don't want to have an ambiguous expression where is it squaring the x or is it squaring the trig function. So the derivative of secant is secant tan, and then the derivative of cosecant is negative cosecant cotangent. And I have a sheet to help you to memorize these 6 trigonometric derivatives. But if you notice that each one of the cofunctions, sine, cosine, tangent, cotangent, secant, cosecant, each one of the cofunctions derivatives is negative. So hang on to that. And there's kind of, if you think about it, when you look at that sheet that I have in Schoology, the derivative of the tan is secant squared. The derivative of the cotan is negative cosecant squared. So you hear a similarity in the answers there. The derivative of secant tan. The derivative of this cosecant x is negative cosecant cotangent. So very similar in names. Helps a lot of things help memorize. When you have to memorize, you look for patterns, and that's one of the patterns that you'll see on that one sheet that I give you. Okay, and then unit circle values, simplifying and manipulating trig expressions, and trigonometric reciprocals in a calculator. So if you're going to have to graph the tangent, you can graph tangent, but if you have to graph the you can graph the tangent by hitting the tangent button, y equals, then put in tan. But if you're going to graph the cotangent, remember you have to graph 1 over tangent, or you can graph cosine over sine. Sine over cosine. All right, so let's get started here. Oh, one other thing is these 2 triangles. Make sure that you understand those, and then be able to say right off the bat that 45 degrees is pi over 4, 30 is pi over 6, and 60 is pi over 3. And 180 is pi. Okay, so let's get started here. So we want to find the derivative of y is equal to sine x tangent x. And so I'm looking at it as a product. And there are not identities where I'm going to simplify this, though I know that sine x is sine over cosine. Sine x times tangent is sine times sine over cosine, but that's not going to make my life any easier. In fact, it introduces the quotient rule and chain rule along with that. So I'm just going to deal with the product rule for this one. So I have dy dx is equal to sine x the derivative of tangent plus tangent times the derivative of sine x. So that's utilizing the first or second plus second or first. Okay, so you've got dy dx is then equal to sine x. The derivative of tan is secant squared x plus tan x times the derivative of sine x, which is cosine x. Now, if we can simplify anything, we do. So we're going to look at the relationships here. Secant squared, that's our answer here. And I'm kind of tending to say, I don't want to do too much to this, but let me show you. Dy dx is equal to sine x And I'm going to leave it as secant squared x for right now. Plus, remember that this is sine x over cosine x. Tangent, therefore, is sine x over cosine x times cosine x. So that would cancel, and that's kind of a nice simplification there. Those would become 1. And then what do we get for our final answer here? Got all this other stuff I want to stay away from. So we get dy dx is equal to, now I could write this as sine over cosine squared if I wanted to, but I'm just going to leave it as sine x secant squared x, and then plus sine x. And there's my answer. Okay, there's example 1. Okay, then we have for example 2, we have find f prime of pi over 6. So we're going to use the quotient rule with this because we have a quotient. So every time I'm taking the derivative, I'm using the notation that says I'm taking the derivative of this. So it's highlighted in green. So I have f prime of x then is secant times the derivative of x. So low d high less high d low. So secant times the derivative of x minus x times the derivative of secant, all over secant squared. So low d high less high d low over low squared, and away we go. So we get secant x times 1 minus x times secant, the derivative of secant x is secant x tan x. And that would all be over secant x squared. Now, I'm going to write it like that for right now. And so we get f prime of x is equal to, and I've got a secant x in 2 terms, so I'm going to factor out a secant x here and here. So if I factor out the secant x, that leaves me with 1, a factor of 1, minus x times tangent x. And that's all over secant squared, secant x squared. So then I'm going to cancel the factor of secant because that takes away one of the factors in the denominator, one of the secant factors. So I end up with f prime of x is equal to 1 minus x times tan x all over secant x. So let's see what we're doing then. We are getting f prime of pi over 6. So f prime of pi over 6 is equal to 1 minus pi over 6 times the tangent of pi over 6, and that would all be over the secant of pi over 6. Now, if you remember your triangle, let me draw another one right down here. So we have pi over 6, give us our 1, 2, root 3, and we're in quadrant 1, so everything's positive in quadrant 1. So we get 1 minus pi over 6 times then the tangent, opposite over adjacent. Here's the opposite, here's the adjacent. So it would be 1 over root 3. And that would be all over the secant. The secant is the hypotenuse, I'll put it like that. Hypotenuse over the adjacent. So that's just going to be 2 over root 3, 2 over root 3. Now, we can simplify this by multiplying the top and bottom by root 3 over root 3. So we're going to get for an answer then root 3. I'm going to distribute here. So I get root 3. And then distributing, I get pi over 6. So minus pi over 6, and then that is over 2. And there is your answer. Okay? Okay, and that's example 2. Example 3, we're using the graphing calculator. I did mark a few things up on here just to look at the graph initially. So we want to estimate the derivative. So remember the last one. Let me go back a second. The derivative has this value. We very often want to get a decimal approximation for this to see what it means because it's somewhat ambiguous, right? We just got f prime of pi over 6 using the quotient rule and then inputting pi over 6. But it's kind of vague in terms of its meaning until we can look at a number sometimes. Okay, so go ahead and put that in your calculator and then get approximate value for that. Okay, number 3, estimate the derivative with a calculator of g of x equal to cosecant squared 4x. So just scroll up a little bit here. So you see where I have cosine cosecant squared 4x here. So we're squaring the cosecant, so I could see that as cosecant 4x, the quantity squared, which is 1 over, cosecant is 1 over sine, so it's 1 over sine 4x squared, the quantity. So when you type that into your calculator, since that's what you're using here, you put it in as y1 equal 1 divided by sine 4x. Make sure you close up the angle itself here, and then make sure you have parentheses around the entire expression, and then you're going to square it. When you square the 1, it's just 1 anyhow. So that's what you would get for g of x, 1 over sine squared 4x, again with the parentheses here. Okay, so what you're going to do is you're going to hit trace 2, and just take a look at this point. Once you have y1 in, trace 2, you might want to have it on a trig window, so you might want to do zoom 7 for a trig window on your graphing calculator. And then what we're going to do is we're going to hit the second trace 6, 2, and then enter. Okay, so I already have my function in there, so I'm going to switch over to my here, and you can see that in y, that's what I have in y1, and I'm going to hit graph, and you can see I'm going to zoom in a little bit on this just to make my job a little bit easier. So I'm going to hit second trace 6 for the derivative, and then I'm going to hit 2 and enter. So you can see when x is 2, I get a derivative of, well, I get the point, 1.02163 is the y value when x is 2. And then I get the derivative at that point is y1, if you look at that, is the derivative of y1 is equal to 1.20197. And I think that's why I have that here. Yes, so here is the answer. So now you've used this function in the graphing calculator already in class, so I think that will come fairly easy. I want to look at a couple of the problems. That's all the example problems that I have for you. But if I look down here on a couple of the problems, such as this one, make sure that when you take the derivative, you're inputting the x value to get your final answer. So you have f prime of x, and we have a 2 times the derivative with respect to x of secant x first. So we get f prime of x, 2 times secant x tan x, and then f prime of pi over 4 is what you're looking for. So you're just going to input pi over 4, so you have the secant x. So instead of x, you're going to put in pi over 4. And then tangent of pi over 4. Okay, and remember when you're doing your pi over 4s, you have that 1, 1, root 2 triangle. Pi over 4 is in the first quadrant, so there's pi over 4. So the secant, remember, is the hypotenuse over the adjacent. Here's the opposite. So I have 2 times the secant of pi over 4 is root 2. And then the tangent of pi over 4 is just 1. So our final answer for f prime of pi over 4, let me squeeze that in there, is equal to 2 root 2. Okay, just one more of them knocked out for you. Okay, and then there was one more. Find the equations of both the normal and the tangent line here for this one. So we have y is equal to secant. Y prime, I'll use, is secant x tangent x. And remember, when we are talking about angles that end on an axis, remember when we have an angle, I'm going to just draw an angle of pi, it terminates at the point -1, 0. So you have an x and y value. So I'm going to use the unit circle to get these. So I get y prime of, I have my derivative, y prime. Now I want y prime of pi. So it's equal to secant pi. Here I'm writing the equation of both the normal line and the tangent line. So I've got to get the slope of the tangent first. So secant of pi times tangent of pi. Okay, so here I get y prime is then equal to the secant of pi is a reciprocal of the cosine. So it would be the r value, and the r value is 1 at this point. Here's your terminal side, right? Here's your initial side. I'll draw that. So you're talking about a 180-degree angle. So the r is 1 on the unit circle. So it's going to be 1 over -1. So 1 over negative 1 is still negative 1, so it'll be negative 1 times, and the tangent of pi is the y over x, which is 0. So our answer is 0 here for the slope. So when we want to find the equation of the normal line and the tangent line, well, if we're looking for the tangent line, we know the slope is 0, right? And the tangent line is at x equal pi. Okay, if the slope is 0, we know that we have y minus, if I put pi into, I get y plus 1. Oh, the point on the graph, here, a point on the graph, point would be pi, and then it would be negative 1. That would just be the point on the tangent line to the graph. So at pi negative 1, so we would have y plus 1 is equal to 0 times the quantity x minus pi. So we just get y is equal to negative 1. Okay, there's the tangent line. Now the normal line is going to be perpendicular to that. So where you have y is equal to negative 1, then the normal, remember it's going through this point, is perpendicular to the tangent. Oh, I have a blank for this, sorry. Y is equal to negative 1 here. So then instead of point slope form, the problem is your slope is undefined. So if we have y is equal to negative 1 going like this on the graph, you can kind of picture it has a slope of 0, right? So the graph of the secant at pi, so maybe it looks like that, maybe it looks like that. Let's see what we have. Either one of those, whichever one it is, and I don't want to tell you which one it is, but if it's tangent at y is equal to negative 1, then here's the point that it's got to go through, right? It's got to go through the point pi negative 1, and we already have y is equal to negative 1, being the tan, here's the tangent. So this orange line must be, since they are perpendicular, x is equal to pi, without even really considering anything else, because we know that here the slope is 0, and here the slope is undefined. The reciprocal of 0 is going to be undefined. In other words, forgot to write the x is equal to pi. So I just thought I'd do one of those. If you have another problem where the slope isn't 0 and undefined, remember you're dealing with the normal having the opposite reciprocal slope to the tangent. Okay, I think that's enough for right now. That'll give you enough to get started on these practice problems and the test prep. Oh, don't forget the test prep. These are great questions. Here you've dealt with, you know that this is some kind of derivative, f prime of x, right? So here you're looking for f prime of a. So when you go down through these two problems, I want you to think, oh, this is some kind of f prime of a. What is a? And what is f of x, right? And then you've got to think, well, what's f prime of x when you handle these? So just tearing apart these difference quotients, okay, using the formal definition of the derivative. Okay, that's it for right now, and I'll see you when I see you. You guys have a great day, and enjoy the calc. All right, this is Alanator out.